Okay, with that, we will get started. Again, welcome to StraightUp Solar's webinar on the technical aspects of commercial installations. Oops. Back it up. My name is Eric Schneider. I'm the Director of Business Development. I'll be moderating today's session. I'm Director of Business Development at StraightUp Solar, and I help manage the Grow Solar St. Louis and Grow Solar Metro East Group Buy programs that are focused on residential and small business applications to solar and making solar more affordable in our communities. I also worked previously at the St. Louis Regional Chamber of Commerce prior to my work here at StraightUp Solar, where I founded the Green Business Challenge. And I'm joined by Steve O'Rourke, our operations and maintenance project developer. Steve's not only a experienced salesperson, I'll let Steve give his background a little later, but a very experienced in residential and commercial sales and holds a NABCEP certification in PV technical sales. But probably more importantly, Steve is very passionate about solar energy. He's got a solar system on his home, and he drives an electric car that's charged at his home. So I'll let Steve do a little broader introduction of himself a little later. Let me tell you a little bit about StraightUp Solar. Our company was founded in 2006 by an orthopedic surgeon, Dr. Dane Glick, who wanted to extend the notion of caring beyond his medical practice into the community here. And he started that by putting a solar array on his house. His neighbors thought that was pretty cool. Asked if they could get one. He got a couple guys in a truck, did their neighbors' homes. Before you know it, he was growing the company here and there, little bit. Now, 14 years later, we've done 1,300 installations. We've grown to do installations in central Illinois with our office in Bloomington. We also do a lot of installations in Metro East, Southern Illinois, and in the St. Louis region. We are 50% residential, 50% commercial company. So we do both residential, government, municipalities, hospitals, institutions, and obviously small and large businesses here. We have 75 employees with over 30% receiving the NABCEP certification. When you look for a solar company, I encourage you to look for the NABCEP certification. That stands for the North American Board of Clean Energy Professionals. We're also really proud for two designations. One is we're part of the Amicus Solar Collaborative, which is a group of about 50 companies all across the country that allows us to buy our products together at a lower price, which we then can pass on to our customers and share best practices. All told, this Amicus Collaborative would be the third largest solar installer in the United States. And finally, we are a certified B Corporation, which means that we put the people and planet above our profitability, and we're judged by a third-party organization called B Labs to make sure we're accomplishing that. So again, when you purchase a product, I encourage you to look for the certified B Corporation label. You can vote for your wallet every single day and choose corporations with that tag. Steve will kind of get a little later into our workmanship warranties, but he is part of the operations and maintenance department and our service department. So we're going to also highlight a little bit of what we can do to service a commercial array. So today's topics, we're going to talk about how you should site assessment, what you should look for when picking a solar array for your business, sizing the system, the different types of equipment from modules to inverters to racking, how a project schedule works when you sign your business up to go solar, what's the time frame, what's all the parts that goes involved in the project management, and then we'll walk you through a little bit of a case study of an example here in St. Louis of a company that went solar here, and then I'll kind of walk you through the steps of how you can get started with going solar here. So with that, I'm going to turn it over to Steve O'Rourke, our speaker. And Steve, why don't you give a little more background about yourself?
Sure. I have, like I said, been in the industry for about 10 years, doing consulting and business development, and passionate about solar. I just recently moved into operations and maintenance, developing our services business, basically to deliver on the promise of solar. So yeah, I do have solar in my home and I drive an electric car. I'm very big into energy efficiency. And so just a passionate advocate for sustainability in general. So the first thing we're going to talk about is doing a site assessment. That's always the, what kind of solar access do you have? Whether it's a roof mount or ground mount. And I'm going to focus largely on commercial here. We look at the condition of the roof. If you're planning to put it on the roof, how old is the roof? When is it going to be replaced? you're getting ready to put something on there for 25 years. And so if that roof is going to have to be replaced in 5 or 10 years, it's not a good idea. You want to replace the roof beforehand. Just having the array on top of the roof is actually going to reduce the amount of UV rays that it's going to get. So it actually does prolong the life of your roof a little bit. Anyway, then the other thing is roof orientation and pitch. If you got a flat roof, it really doesn't matter. I mean, we generally want to be south facing, and so we'll probably align with the building. So if your building is like, facing southwest, southeast kind of thing, we'll pick whatever angle works best. We can also orient it to face due south to optimize it, but generally we tend to go with the building orientation. If you've got a sloped roof, we look at the pitch of the roof, so these are just things that affect the production. A 30-degree tilt, 180 degrees southwest is going to be ideal, but we can vary from that and not lose a whole lot of production. The other big thing is looking at roof obstructions. If they're vent stacks or HVAC equipment or whatever's up there, we have to be mindful of the shadows that anything's going to cast. Also, if you have a lower roof and there are trees near the building, we have to be mindful of the shade. So we do shade analysis and shade mitigation techniques that we'll talk a little bit about. And of course, we're also going to look at the structure of the roof itself. We'll look at the trusses, and we have a structural engineer who's going to certify that the building can support the additional weight of the array, which is not much. And then the last thing we're going to do, we're going to look at the interconnection strategy. Is how are we going to connect into your building distribution system? Are we going to connect right into a panel? Are we going to connect, on a load facing or on the meter facing? Which side of the panel are we going to connect? If you're doing a ground mount, we have to look at soil conditions. Are you on really rocky ground? It's sandy, loamy. It just really kind of depends on what the soil conditions are, which is how we will, whether we'll do a ballasted ground mount or we'll do something where peer driven, and whether, the equipment that we'll use to drive those pylons. There are fencing requirements for solar if you have a ground mount to, while this is all fairly safe, we don't want people getting up. This is high voltage electricity, and we want to prevent people from playing with it or messing with it. Again, we also look at shading on the ground mounts as well. Ground mounts do, depending upon how far away it is from the interconnection, there are trenching costs. So usually a roof mount is going to be the most cost effective. And then we also look at canopy options, which can have, multiple benefits. So that's kind of what we do when we do the overall site assessment. Next slide. So the next thing we're going to do is the sizing of the system. We go back and we look at your historical energy usage. Generally, we want to get at least 12 months of utility bills. I like to get 2 years of utility bills and see, how close was the past 12 months to the previous 12 months to see if your energy usage is pretty consistent. Looking at month to month, obviously, HVAC equipment or HVAC energy is going to vary depending on weather. So, we don't necessarily weather normalize the data, but it just kind of depends on the application. But the big thing is we want to size the production of the solar array to the consumption that you're accustomed to. Again, we're going to look at the rooftop capacity of the available ground space, and we'll try to match those two out. In some cases, we have much more roof space than we need. In other cases, we don't have nearly enough. And so we just do the best to utilize what you have. We also look to find out, have you done any energy efficiency improvements? If you have not, then we want to make sure that we don't size this thing so that we're going to overproduce when you do the energy efficiency improvements. So it's just something that we ask about and we want to be mindful about. The net metering implications, I have a whole slide on net metering. We want to make sure that you're not overproducing greatly in any given billing cycle. We'll explain a little bit more about that. Bottom line is for a 100 kW array, that's going to require about 10,000 square feet of roof space, of available roof space. That includes setbacks and getting out of the roof obstructions and stuff like that. That's going to produce about 125 megawatt hours a year. So if you look at your utility bill, and when Amerns does or I should say, your utility typically will provide a greater analysis of here's how much energy you used, rather than just looking at a single bill. So net metering, when you've got the solar, you've got two sources of energy, the grid and your array. And so your electric is going to pull from the solar first. And if it needs any more, if it needs more power than what your solar array is producing, it's going to pull that from the grid. If you are producing more power than you're using, then you've got excess, and that's just going to be exported to the grid. And so you have a bidirectional meter that keeps track of what you pull off the grid and what you put on the grid. At the end of the month, you're going to pay for the net difference between the two. So if I pulled 100 units of energy off the grid and I put 40 units of energy onto the grid, then I'm only going to pay for 60 units of energy. And so that's the whole notion of net metering. The laws vary by state. In Illinois, they actually have a true-up period that's on a monthly basis, on an annual basis, where you can carry over. You can actually create a balance of kilowatt hours, a bank, if you will, of kilowatt hours that you can use in the wintertime. In Missouri, it's at the end of the month. If you are a net producer, then the utility is only going to pay you for the avoided cost, which is less than 3 cents. So the other thing about the true-up period is, I'm sorry, the cap on net metering, it's 100 kilowatts in Missouri, whereas it's 2 megawatts over in Illinois. So for equipment, we've got the primary thing when people think about solar is the modules themselves. There's crystalline silicon and there's thin film. By and large, the vast majority are all crystalline silicons. There may be monocrystalline versus polycrystalline, and you see the polycrystalline is more the blue color, and the monocrystalline tends to be more of a darker black. Generally, when you see the diamonds, that's a monocrystalline also. There are different cells. You see the different blocks that make up the solar array itself. It used to be pretty common with 60 cell. They're moving more, particularly for commercial applications, to 72 cell, and even the latest stuff is 78 cell. SunPower is another. We deal primarily with RAC. We also do LG. LG has over on the far right is a black on black. It's really a stealthy, attractive module used a lot in residential applications. But we also use SunPower, and SunPower actually has 96 cell modules. So, but for the most part, the industry standard tends to be around 60 and 72 cell. All these modules have a 25-year power production warranty, so they just guarantee that it's going to produce at the end of the 25 years, it's going to produce 80% of what it did when it was brand new. Most of them have a linear warranty where it's like anywhere from 2% or 0.2% to 0.7% degradation every year. SunPower has the lowest, 0.25% degradation per year. And so we factor that in when we're looking at energy production over its lifetime. Everybody asks about hail. These are tested to handle 1-inch hail at 50 miles an hour, and that's a drop, a direct hit. But depending upon the angle of the hail and the angle of the module, a lot of times it'll hit it, it'll just skip right off. So it really just depends on how it's hit and the size of the hail. So we measure solar panels in terms of their DC capacity. Their standard testing under standard test conditions. Generally, solar panels are between 300 and 400 watts. I mean, there are some out there that 60 cells that are 270, 280, 290. But most of them are around 300 now for the 60 cell. And then for the 72 cell, there's like 350, 400, and even higher than that. We're doing a lot of 375 watt REC is the one in the middle there. So if you think about, I've got a 300 watt module. If I have 100 of those modules, you take 100 times 300, that's 30,000 watts or 30 kilowatts. So just to give you a sense of the size of an array. Next slide. So then the inverters are really the heart of the whole system. The inverters are what convert the DC energy into AC energy, direct current and alternating current. And that's your building distribution is running on AC. So we have to convert that DC to AC. There are some losses in that. But again, the inverters do have all the smarts. They're taking, all these strings of arrays or strings of modules, and converting that into DC energy or AC energy. We use a lot of SMA. SMA has a 10-year warranty with a 20-year. You can have an extended warranty up to 20 years. They tend to be the lowest cost option. This one that we're showing here is actually a roof-mounted. It's a 50 kW inverter. Then SolarEdge, depending upon what version of the electric code your permitting jurisdiction has adopted, there is what we call rapid shutdown, and so what this does is requires the roof or the solar array to shut down production. And so with both, if you have controllers at the module level, it can shut down that module and not produce, there'll be no current on the electrical lines running to the inverter. So SolarEdge has power optimizers on each module, or actually in some cases they have one optimizer per a pair of modules. And that's also to mitigate shading. So there's the Christmas tree effect, Christmas tree light effect. You know how if one lamp is out, the entire string is out? The same thing with solar. If one is out, the whole thing is out, or if one is underproducing, the whole thing is underproducing. And so if you have shade issues, it's nice to have these optimizers which optimize the production of each module or each pair of modules. Enphase makes microinverters, and this is similar to the optimizing, except it's actually a small inverter on each module. And so you're optimizing the production, and you have so you have AC power coming from the module, so you don't have any high voltage DC power coming into a string inverter. They also offer a 25-year warranty on those microinverters. SolarEdge offers a 12-year warranty on the string inverter and 25-year warranty on the optimizers, and then the inverters are also, you can get an extended warranty for those too. The inverter location is a big thing we look for. Typically, if you're doing a ground mount, we're going to mount the inverters right out next to the array to minimize any power losses from the DC components. So the AC will travel from the inverters out of the array into the building. We're going to look to, we go and find out where your meter is, where your electrical room is. We generally want to install the equipment somewhere where the electrical distribution equipment is. If you have room on the inside of your electric room, that's ideal. When you don't have the inverter out in the elements, but the inverters are designed in NEMA certified cabinets, so they're designed to handle weather. But if it's really hot, they're going to be affected somewhat. If it's really cold, it stresses the equipment more. So if they're in a climate controlled condition, it's better. So then the last thing is the racking system itself. For roof mounts, we generally use ballasted racking systems. This is ideal for low slope roofs, flat roofs. This is going to minimize any roof penetrations by having, rather than mechanically fastening the racking system to the roof, we just use concrete ballast to hold it down. Those ballast designs are based on wind loads. In Missouri, in this area, I should say the St. Louis area, we use 90-mile-an-hour wind loads. I will tell you that St. Louis County has been requiring some mechanical fasteners. They're taking into consideration seismic activity, but they're not taking into consideration friction. So that's actually currently under appeal. They're not following the seismic suggestions or what's going on out in California. And so we're hoping that St. Louis County will soon adopt a best practice. A lot of people want to know what the weight of this is. It's typically around 4 to 6 pounds per square foot. So generally doesn't add a whole lot of weight to the structure. What you see here is a landscape orientation. So this is going to be at a 10-degree tilt. You can also increase the density of how much you can get on your roof by doing a 5-degree tilt in a portrait orientation. So if we were to just turn these things around and put the short edge slope at the bottom of the slope, that would have a smaller, lower tilt, but we could get get significantly more solar on the roof. A lot of people want to know what the project schedule is. The schedule is going to depend on the size. Obviously we can turn around a smaller project more quickly than we can a large project, primarily due to construction, the time of construction. But there's also just the pre-construction stuff. We're going to get out and do a technical on-site to firm up everything that the person the salesperson who sold does his best job. Like that's what I do. I get out and do my best to measure everything as accurate as I can, but I'm not an engineer. So we have our technical folks come in and do detailed site scoping. And then we've got a preliminary design that we can base an interconnection application, an SREC application, the Solar Renewable Energy Credits. When we get those filed right away, the utility can take up to 90 days to turn around an interconnection application. Anyway, and then once we've got the detailed design, then we actually create the permit drawings. We have to submit that for permits. So we can't begin construction until we have the permit and the interconnection approval. Once we have that, we begin the installation. And of course, generally we're going to order the equipment once we got the permit drawings. In some cases, if we're not sure if this is going to get approved, if it's something that's unconventional or what, then we might wait before we order the equipment. But generally, we're doing things that we've done over and over again, and so we know that once we've got the final design, what kind of equipment we'll need. So we do the installation, the inspections follow after we complete, and then we have permission to operate by the utility. Post-construction, you get to your incentives back, and then that's when we begin operations and maintenance. We start monitoring and making sure that the system is performing as expected. Next slide. Quick case study, which we have here is the Fair Mercantile building. It's down on the hill in St. Louis. This is a 99 kW array, just under that 100 kW net metering cap. 266 REC 375 watt modules. Again, these have a 30-year lifespan. We've got a pair of SMA tri-power inverters that have a 15-year lifespan that we expect. When we looked at the utility analysis, this was going to produce about 28% of their total loads. The project cost was about $200,000, total installed cost. Their net cost after the incentives and taxes was just $50,000, under $50,000, so 25 cents on a dollar. The incentives aren't quite as good. This was using a 50 cent per watt rebate, which is now 25 cents per watt. So the cost of that now, or this would now be about maybe $65,000, $62,000 worth. Anyway, but the 30-year energy savings were $430,000. So you spend $50,000 to get $434,000 in energy. Now that's assuming a 2.5–3% rate increase every year. We don't know what the rate increase will be, but based on that, the payback would be 6.7 years. The thing that we like to do, I like to talk about the levelized cost of energy. That is when you take the total amount of energy that it's produced, that it's warranted to produce in its lifetime. And we use a 30-year lifetime. It's a 25-year warranty, but we generally just use a 30-year lifespan. The solar will continue to produce beyond that, but you got to draw a line in the sand somewhere. So you're buying 30 years worth of energy, And we take your net cost after incentives, that $50,000 cost is your fixed cost. So you're buying that 30 years worth of energy for $50,000. We calculate the levelized cost of energy, that's about 1.5 cents per kilowatt hour. It says per watt, but it's actually per kilowatt hour. Right now you're paying, depending upon what rate structure you're on, you're paying anywhere from 6 or 7 cents per kilowatt hour up to 8 or 10 cents per kilowatt hour on commercial, or 10 or 12 cents a kilowatt hour on residential. And you're getting that for 1.5 cents per kilowatt hour for 30 years worth of energy. So it's a great investment for energy predictability and security that you can benefit from over the long haul. I think that's it, Eric.
Yeah, thank you, Steve. I'll take it from here. Thanks again, Steve, for going over kind of the technical aspects of commercial installations, all the aspects of site assessment, the products, the different products that we use, and then going through that case study. That was very helpful, even with how the incentives in going solar here. We do have a couple questions, Steve, so stick around. I know I want to pass on a couple questions that we got from our chat room. I want to close with a great program that's happening in the St. Louis area. It's called Renew STL Solar, and it's a group buy program designed for businesses in the St. Louis area. It's organized by Renew Missouri and Washington University, part of their initiatives to reduce the amount of greenhouse gas emissions in the St. Louis region and to advance renewable energy. This is the first of its kind that we believe in the Midwest of a region offering kind of a group buy program for businesses here. And that provides customized solar solutions for businesses, governments, hospitals, school districts for a 35 kW system up to a 500 kW system. And the program works this way, and StraightUp Solar was really proud to have been selected in a competitive process to be the sole solar installer for Renew STL Solar, which means that we are offering a lower than market rate to businesses who are interested in going solar. But in combination with that low rate, we are there's a rebate program. So as more people sign up and go solar with the program, greater rebates up to 4% will be passed on to the businesses who participate in the program here. So this is a great time to get involved in solar if you're interested as a business. Steve also mentioned the incentives in terms of the federal tax credit and the Ameren rebates, which are federal tax credit steps down next year from 26% to 22%, and the Ameren rebate only has a couple of years left. So this is a really great window of opportunity for businesses who are interested in going solar. If you're interested in learning more, go to the Renew Missouri site, Renew STL Solar, or contact Andrew Linares. He's the program manager over there, and he'll get you started get you into the program. So if you're interested in going solar, please contact us at StraightUp Solar at 844-97-SOLAR. We can get you started. Just share us some of your energy information and your address. We'll give you a general sense of if solar is going to work for your building here. Then we'll get you in touch with a project developer like Steve or other commercial business project developers who will develop a customized solution for you, lay out those panels as Steve showed in the site assessment slide, and hopefully get you a good price for your array. You'll sign the contract, and then we'll move you over to our project management phase. StraightUp Solar is a turnkey solar installer, so we do all the engineer design work, the permitting, and the application process for you. There's nothing you need to touch in terms of the whole process. And then we'll send out our certified crew, our NABCEP certified crew out there to install your array. Steve mentioned the schedule out there. It could range anywhere from 4 to 8 weeks for an installation on a big commercial array. And then we'll get you charged up and you'll start enjoying your solar array and reducing your energy savings going forward here. So with that, here's Steve O'Rourke's contact information. You can reach out to him at steve.o'rourke@straightupsolar.com or call him at our phone number 218-2663 or go to our website at straightupsolar.com. I wanted to mention this is the third of a 3-part series on helping businesses go solar. If you go to our YouTube page, on which you can access at youtube.com or through our website, you can watch a webinar on how does solar help your business cash flow, and another one on commercial and nonprofit financing options for solar. So both these webinars are on our YouTube site. They go over the incentives, they go over the different loan options that you have for going solar, and provide some good examples of how solar can work for your business.